Okay, let's take a look at this problem. We got the integral of x squared dx. Now we got x to a power. What we do is we add 1 to our power and divide by our new power. Then we put a plus c on there. So that'd give us 1/3 x to the third plus c. And that'd be our answer. Now for these down here where it says graph those, you just plug those in your calculator. For example, let me do one. Go to y equals, I'm going to do a clear and then do zoom 6, set my standard view window back. Go back to y equals, and I got 1 divided by 3, x to the third. So I do x caret 3 minus 3. And then you go down to y2, you put the next one, then y3, and then y4. And by graphing them all, x caret 3 minus 1. Now if I press graph here, I'm going to see the two graphs. There's one of them, and there's another one. Now it does say to change your window setting, and how you can do that is you go to window, your x min will be -3, enter, my x max is 3, x scale is fine by 1, and here it'll be -5, +5, and then graph. And this way you'll see it a little bit closer to what the picture's asking for. Now once you're done graphing all four of those, and you should do them all on the same viewing screen, y1, y2, y3, y4, then once you're done you do zoom 6 to set your standard viewing window back. Then this talks about what these represent. Each increase in c of one shifts a curve up 1 unit. You see these are shifted up 1. You might say, well, they're shifted up 2. Well, each one of these little tick marks represents 0.5. And it says find the slopes of several of the curves at x equals 3, and check that in each case the slope is the square of the x value. This verifies the derivative of each curve is x squared, and so each integral is of x squared. Find the slopes of several curves at x equals 3. Well, if we find a derivative, we have x squared. I think those were all x squared, were they? Or were they x to the thirds? X to the thirds. Just in general, when I got x to the third, take your power, put it out in front, lower it by 1. That gives us this for our derivative. And let's see, find the slopes, or dy dx, several of the curves at x equals 3. Okay, so like 1/3 x to the third minus 3. Now we're talking about the derivative. 1/3 x to the third minus 3. So y prime, take your power, put it out in front. 3 times 1/3 drops away, and that gives us x squared, and -3 drops away. Then you plug in the x value they're referring to. They're saying x is equal to, what are they saying? X equals 3. Now, y prime changes to our slope notation, so that's m equals 3 squared, which gives us m is equal to 9. And that's where they get the 9 at.